Silicon multimedia.
आशीष सर।
यस सर, बोलिए।
कैन यू स्टार्ट नाउ?
ओके सर, वेट टू 2 to 3 minutes so that
already 71 people joined, so I can start. Start, and I think sharing option is now enabled. Sharing option is enabled, na sir?
Yeah.
Okay sir, so you can start now.
Okay. Okay, good afternoon all the students. So this is the so it is my privilege to invite Dr. Prabas Banerjee on the topic of process on innovation development and technology readiness level, that is TRL, and commercialization of lab technologies and technical transfer. So This is the first workshop in the academic year 2021 to 2022. So according to the Prabas Banerjee academic scenario, he is completed MTech from Kalyani Government Engineering College, and after that he is completed PhD from NIT Durgapur. So I would like to invite Dr. Prabas Banerjee to brief off about this topic. So now I will hand over this session to Dr. Prabas Banerjee. Prabas Banerjee, sir.
Thank you, Shamim sir, for your kind introduction. Thank you. Now from this on, I will take this course. That is, as Shamim sir has already told you, that this talk is about the process on innovation development and technology readiness level, as well as commercialization of lab technologies and tech transfer. So before beginning this talk, I would like to say to the participants, like this is not it is not going to be your a class. It will be an interaction session. Okay, so we have joined here and we are going to interact, and we will share the whatever knowledge we have, and we would would love to hear from the participants, like what do you know, what is your current feeling about the current scenario, and the innovations that that keep on going in your mind, and you would like to express your thoughts with us or share your thoughts with us. So by saying this, we will move ahead. Okay. Thanks. So first of all, this is a very basic slides I've prepared. That the thing is about science and engineering. So many people are still in idle that what is science and engineering. For those to clear their doubts a little bit, science is about intellectual and practical activity encompassing a systematic study of the structure and behavior of physical and natural world through observation and experiment, while as engineering is about the application. Sorry. Okay. Engineering is all about the application and your expertise to make a judgment, to develop ways to utilize a particular process or a product, which can be both economical as well as is beneficial for the mankind. And also you can today there is a buzzword that buzzword is sustainable development. So in a way, engineering helps us in developing a product in a sustainable way, so that there is a win-win situations for all. And the word technology is derived from the Greek word technologia, meaning systematic treatment. Now in this era of Elon Musk and other Jeff Bezos, the buzzword is about innovation. So what is it, innovation? Innovation is a generation of new ideas, goods, services, or practices which are intended to be useful throughout the society. Okay, so innovation has punctuated and changed human history. So the major innovations are the development of electricity, steam engines, motor vehicles. So innovation and inventions are a little bit different. Invention is inventing a new thing, the mankind has invented fire some lakhs years back. So that is a kind of invention. So we are not talking about inventions, we are talking about innovations. So innovations are those little ideas which when applied will tweak the entire technology or the process, and the new dimensions will evolve, and that will be great beneficial for the mankind. And a small example would be your like the what do you say, these in the service sector, the e-commerce. So those little things were there, but when applied in a large scale, it has hugely impacted the society. So now the three legs are the innovation, education, and research, which goes hand in hand. Here we are talking about the legs, but these are the three things which goes hand in hand. Without one of them, the entire process will wither away, or will not exist. So this innovation, education, and research coexist. So you can see that these are the three legs: education, research, and innovation. They are the three legs rather than the three nodes, or the, since we are replacing the legs because we are moving forward. So this is the infinity circle, right? So now we are since this is about the innovation of development of a new product. So what is that definition? Is the development of original product or product improvements, product modification, and new brands through firms' own R&D efforts. So this is all the basic definitions. So the new product development strategies can be, new products can be obtained via acquisition or development. As I've told you that you can develop a new product by changing a small thing in the existing product. By making a small tweak here and there, you can develop a new product. So but new products suffer from high failure rates. Several reasons account for failure. Now this slide mentions about the product management life cycle. So there are various stages in order to manage the life cycle of a product. So the number one stage is your innovation stage. Then after the innovation stage comprises of the generation of ideas, creation of initial proposition, where these ideas will get utilized. Then the analysis part, like sorry, I request the other participants to mute themselves. Okay. Participants, is my slide is visible and my audio is visible? Audio is audible?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. So till
Clearly
now,
audible, sir.
how do you find the interaction, this slide presentation? So what are your thoughts?
It's going good, sir.
Okay. So okay, after certain slides we will stop and discuss. Okay, good. Then after the innovation, your analysis, then after the analysis comes the development part. Then development part, we should consider design solution and deliver, demonstrate the requirements. If the requirements are made, then you can see that if something is missing, then we will again go to step one. Okay, then after the development we will go to the market. In the market we will validate or we will find whether the market, which market is suitable for the current product we are going to develop. And then the in life, like every product has their own life. After that, the product will we need to, like from that the product will we need to innovate something more, so that the product does not cease to exist, it remains in the market forever. For example, your the Colgate toothpaste, okay, so it has exited its life cycle, because no amount of new technologies it is required, but it can sustain all markets. So this Colgate toothpaste is an exception. But apart from that, one example that is your ambassador cards, ambassador or the taxis, yellow taxis, you don't find, right, in the market anymore. Participants, do you find
Yes,
taxis?
sir.
Do you
No,
find
sir.
taxis?
No, no, no.
No, sir. No,
Yes.
sir.
Why?
Because it oldest version.
It was the older version. So here comes your main thing, that we need to like develop the next version. Okay, so you're correct. You have said that it was an older version. So the ambassador or the Hindustan Motors were unable to find or meet up the next version of the ambassador, and hence the ambassador of the yellow taxi ceased to exist. So it just vanished from the market. Unfortunately, it was a good car, but due to some management failure, due to some innovation techniques, it failed to stay up in the market. Why? Why? Participants? Anyone?
Sir, because of innovative ideas.
No, that is the thing. But mechanical people, anybody?
Sir,
Mechanical?
because
idea,
it
sir.
does not have new features like
That
today's
is
car.
that is from a design perspective. Sorry.
Sir, but as compared to that one, many new facilities on other vehicles has introduced that make
Okay,
a
okay,
replace.
okay. No, that is very good.
Sir,
I
due to
appreciate.
emission norms, sir.
No, they were in a position to produce Bharat 4 models, so that wasn't an issue. Any other?
Sir, design.
Design is a factor, but it was a robust design. There was not a good safe car other than Ambassador. Ambassador is very safe, so design wise it was good, but you can say the look wise, the elegant, it was not that elegant, you can say that. It was not sleek in design. In the design, it did not have that cutting edge, right? So so like the your bullet once used to run in Indian roads, but after Hero Honda and Honda, all those came, Bajaj came, so eventually it slowly began to disappear. Now in the last decades and so, bullet has again gained footprints in the Indian markets and Indian roads. So now we are finding many more bullets in the Indian roads. So but they have made certain changes in their design. They have made certain innovations in their ignition system. They have always improved their mileages. So these are the things. But going beyond the design and the product itself, I would suggest that the mechanical people might know that the nowadays in the automobile sectors we are using flexible type of manufacturing system, while the Hindustan Motors used to use fixed type of manufacturing system. So they weren't unable to change the model at a faster rate compared to their counterparts. So if you ask Maruti Suzuki to change the product of the product design of the Suzuki within you say a year. They will be able to do that because they in their company they have established their company based on flexible manufacturing system. Okay, but since Hindustan Motors were established quite a long back, and their organization was not upgraded, not enhanced, not innovated, so they failed to meet up with the current demand scenarios. So this was I would say a classic example, a case study on the product management life cycle. So moving on. So so the project management life cycle is used for tracking of what's happening in the market. So the next phase of the innovation is that are we ready for the current market? Who is going to determine that are we ready to take the next big step for the current based on the current market? So the answer is your readiness levels. So what are the readiness levels? The readiness levels are number one, your technology readiness level, your manufacturing readiness level, and the third and the ultimate one is the investment readiness level. We will be focusing more on the technology readiness level, a little bit on manufacturing readiness level, and a very less on investment readiness level, because investment readiness level is mainly based on your management type or the business model. But we will be focusing more on technology readiness level, because in with this method we can keep track of the new products which we have in our mind, and we can say that yes, the developed product is in which stage, and whether we can move ahead from one stage to the other stage. So in the short form, it is in industry it is called TRL, technology readiness level. A manufacturing readiness level is abbreviated as MRL. So TRL methodology was originated by Stan Sadin at NASA headquarters in 1974. TRLs is a measure of a maturity level of technology, is research, development, and deployment phase. The whole idea was to standardize the system to understand at which technology our product is. Okay, so this was the TRL was first came into light or came into this world, and thus we are studying it in 2021. So you see that NASA was way advanced, and we are slowly trying to gain into the footsteps of what has been developed in 1974. So TRLs are based on a scale of 1 to 9, with 9 being the most mature technology. So the the penultimate is the MRL. MRL, it is not a common term among research. It is used to manufacture a product, and also if we are trying to build a business through the process. It was developed again by US under the Defense Development Program, DoD, or a Mantech program. It was developed for a missile technology. Then your IRL is mainly focused on the business readiness of a particular startup. It is primarily used for startup when they are not trying to bring or they are not trying to develop a new product, or they are not trying to bring anything new to the table, but they are more focused on starting up a new business. So since we are more into technology, so we will be focusing on technology TRL and MRL. So you see, we have represented here, sorry. In this slide, the 9 levels are being represented, and the phases 1 and 2 is your research phase. I will be talking about this thing. Then from 3 to your 6 is a translation phase or the development phase, and from the mid 7 to 9 is the commercialization phase. So you can see in the medical, we are all know that we are impacted by the COVID. So you see, we have seen lots of news like the Covaxin, they have released the phase 1 trials. Covishield, they are in the phase 2 trials, and this Pfizer is in the latest, that is the phase 3 trials. So you can see that these are all was based on your this TRL. So after the phase 4 trials, it only came to the market, and we were able to get a jab of the individual vaccines. So you see that everything works on a principle, and that principle, your new product is being governed by the TRL. That should always keep in mind, because you are the young innovators, I would say. Like if you have any product in mind, if you are working on that, and this TRL will help you in the measurement or the determination of the scale in which your product or the stage is your product is in. So there are the number from 1 to 9. In the number 1, these are the basic principles is observed and reported. This is the initial you can say the scientific research which we as researchers do. Studies on basic material properties, principles which are qualitatively postulated. Basic principles are observed and focus on the fundamental understanding of the process. Okay, so this is the lowest level of technology maturation. You can say that suppose if you want to design a rope. Okay, so first for the rope material which we use in our homes, you can see or you will see or observe that it is made up of synthetic. So for that synthetic material, we will first have to determine its property. Then we will study whether there are those synthetic fiber which we have developed can withstand a certain load, can withstand a certain torque, and then we will move ahead. So since we want to determine the mechanical properties, the physical properties of the synthetic fiber. So this is the stage where in this stage we determine the properties, or we do the initial scientific research. And moving on to the next phase is that the application. The once the basic principles are ascertained, then in the next level is the practical application of those characteristics which we identified in this next in the previous TRL. So you can see here it is written that the application is speculative. So we are not certain, like we can only speculate that the things which we develop or which we are going to develop can be applied in certain applications, but in the long run you might find that that it is not suitable. So you have to change and move on to the to another more suitable application. So the another in this we do another work is the experimental work. which is designed to corroborate the basic scientific observations made during the this TRL1. Now in the TRL3 stage, at this stage, this active research and development phase is initiated, which includes the analytical studies to set up the technologies into an appropriate context, and the laboratory studies to physically validate what we are what we predicted or what we are going to develop. So the examples include research on materials, like I've told you that since you have trying to develop a new synthetic material for rope. So the examples include your research on materials, component processes that are not integrated. So let me give you an example. Suppose you are you want to develop an all-terrain robot. Okay, so anybody from the CSC department who wants to who know what is an all-terrain robot? Participants?
Sir, all-weather robot.
No, all-terrain I'm talking about, all-terrain.
So the type of robot which has capability to go on the any type of such as land, water, or everywhere.
Okay, very nice. Like it can have a motion, linear motion. It can climb a slope. Okay, so you can say that it is an all-terrain robot. So for that, if we design a spring system, right? So or the wheel part we are designing. So those are the components. And if we in this phase, we will make sure that each of the components of the process works, but in a separate way. So the next is the supporting information includes the results of the laboratory test performed to measure the parameters of interest. So again, if since we are talking about laboratory test, so if we go and find, if you are putting one sensor, so we will see that whether the from the sensors we are getting the required feedback, whether our servo motor control mechanism is working properly or not. So these are the things we need to take care of in this stage. So so this stage has been named as critical function proof of concept, because whatever concept till now we have developed, we are in the phase of establishing that concept for each component. Remember, for the each component. Okay. Now this is a stage 4, where the laboratory testing, validation, and prototype component and the process. The goal of this TRL4 should be narrowing up possible options in the complete systems. Now, in the phase 3, we have completed the application, the laboratory test of individual components. Now we are about to launch for the integrated system. So it requires design and development and lab testing of technology components, which we are trying to develop. The basic technological components are integrated. So slowly we will put one by one the things which we are trying to integrate and make the final product. Suppose if you are trying to make a robot, so first you will put your chassis, then your the servo mechanism, then your sensor, feedback control, all those things which you are going to put one by one and check whether those systems are working. So you can see that statement is particularly very important. It suggests that this is the first step in determining whether the individual components will work together as a system. So this will give you a fair idea about the system. So in this phase, the TRL 5 phase is the laboratory testing of integrated system or the semi-integrated system. Okay, since we were in the process of integrating in TRL 4, now since we have reached to a level where we have a semi-integrated process, so in this phase we will try to validate or mechanically test the product. So the system tested is almost a type of a prototype. Scientific risk should be retired, like the scientific risks associated with TRL 1 and TRL 2 should be retired at the end of TRL 5. So nothing like the assumptions, the hypotheses, the principles which we have considered in TRL 2 and 1, those are correct, those are working, and those are bulletproof, and they will not change under any circumstances, under any weather or under any conditions. So those risks should be eliminated in this TRL 5. So the next is your TRL 6 is the prototype system demonstrated in operational environment. So now we have developed the entire product which we had in mind, and after the development, now we will test the new product in the operational environment, in environment which we are trying to set the product in. Okay, so one example is your all-terrain robot. If we have developed, if one part was to the one of like your team was developing the wheel, another team was developing the balancing system, another team was developing the feedback control system, another team was developing the servo mechanism system. So all those have been integrated, and the all-terrain robot has been formed. So we will test that all-terrain robot in an operational environment, in a real environment in which the robot could go and work. Suppose now we are trying to develop, due to the recent news you can hear or might know that there was a blast at the Mumbai port. So in that the Navy, like some person got trapped, and they went, due to the blast, they were submerged. So for that we were unable to rescue, unfortunately we were unable to rescue those peoples, because we did not have the technology of under water vehicle. So now the government, or the main focus of the government, is to develop an unmanned underwater vehicle which will go underwater to levels which humans or the divers or the expert divers are not even able to go to, and that the underwater unassisted vehicle will go and perform the rescue operation. Another example I can give you is that in that Thailand, 9 boys were trapped. So we due to some expert divers, we were able to rescue those 9 boys, but they were stuck in that cave for about 3 days. Okay, so the next big step or the challenge is to develop an underwater vehicle. Okay, so if we have developed an underwater vehicle, now that vehicle works fine in a swimming pool. Let us suppose it is going good in the swimming pool, but if we put the developed vehicle in the ocean, so whether the underwater vehicle which we have developed will be able to sustain the currents, the salinity, the density of the ocean water or not, that we will all check and ascertain in TRL 6. Now this is the integrated pilot system, in which the system prototype is an open environment. So we already said that, and this is a continuation of TRL 6. This represent a major step up from TRL 6, requiring demonstration of an actual system prototype in a relevant environment. Final design is virtually complete. The goal of this step is to retire engineering and manufacturing risks at this stage. Now the system incorporated in commercial design. So this goes again into business thing. Examples include full-scale volume manufacturing of commercial end product. So we have developed the product. Now we want to disperse our product into the entire world and let people have the benefit of the new product. So we are into the manufacturing stage. Lastly, the system proven and ready for full commercial deployment. So this is the TRL 9. So up till now, you can see that we were able to define each stages or each TRLs from 1 to 9. So you can see I have represented here that from this stage, from 1 to the mid of 3 stage is a basic research. From this, the continuation of applied research happens from the halfway mark from stage 2 to 5. Then from 5 to 7 is a technology development, and then from 7 to the rest is a prototype and system development. So naturally, from the large businesses, after you have approached a large business concern, these large business are likely to take up your product, because they will study your product and they will be really be interested. If they are really interested, then they will take from stage 5. So when you will going to approach the company, you will say, look, I have reached my product is in TRL 5. So if you are interested, you can have a look into our product, and from that you can expect some healthy funding. And these small businesses thrive from 2 to they are 6 or 7, because there are many components related to the product which are new to the market. So the small businesses might be interested in a little bit small innovations, small tweaks to their existing like product. So they might be interested. So according for funding, government generally funds nowadays. Government used to fund from the technology development. Earlier, the funding was available till applied research. After that, generally the entrepreneurs were asked to get funding from big business houses, and private sectors fund from like they generally used to fund from 3 to 9, because they will come to know if you are developed a good product or not. They will have a knowledge, and they generally fund from 3 to 9. So government labs or the labs, they can move till your TRL 6. In the academia, we can move up to TRL 5. So this is our limit. For the government labs, they get good fundings, so this is their limit. So the challenges of the TRL levels. So mainly, as I've told you, the universities, they deal with 1, 2, 3 TRL levels, but the main challenge arises from TRL 4 to 7, and 8 and 9, as I've told you, is the industry. So the challenges include the product challenges, business challenges, innovation challenges, and process challenges. So this, if you have anything in mind, so these are the challenges which you are going to face. That is, if you have a product and unfortunately you have another product which is very similar to your product, so you want to make your product more better, like better than the existing product of your competitor. So this is number one challenge, and the number two is the higher performance and more sustainable. So as you say that this, without sustainable buzzword, you cannot develop a product. Your product has to be sustainably good. Sorry, anybody? Okay, so another one is the business challenges. Number one challenge will be to produce a lower cost model, faster production times, higher return on investment, because these are the things which your funding agency or the industry which you are planning to sell your product or your idea is going to look into. Now the commercialization factor will come in your innovation challenges, marketing and sales research, whether this product will be marketable, and whether you can sell this product and tandem. So for that you need customer feedback. So one of the innovation challenges is that the Nokia it did not study the market properly and it failed. So now it is finding difficulty to gain its foothold in the current market scenario. You might all agree that. Now the process challenges are the universities, like many universities lack resources or experience, and industries had no time or interest in your innovative product. So these are the challenges from TRL 4 to 7. Once you have crossed these challenges, then you will be in your 8 and 9. I would like to ask the participants to please mute themselves. If you have any query, then you can say, otherwise please mute. Okay, thanks. So this is another topic, that is the manufacturing readiness level. So before moving on, any questions do you have? Since we are in a we want to interact. Any questions? Any questions? Or do you want to say anything? Do you have any ideas in mind? Anybody? Hello? Hello? Participants?
Yes, sir.
Yes, sir.
Do you have any questions?
So, may I tell something, sir?
Yes, please.
Yes. So, student, if you have any query, then you ask with sir, Dr. Prabas Banerjee, sir. So, if you have any doubt, so you ask.
Okay. So
I have a question, sir.
sorry.
Sir, one question.
Sir, I have a doubt regarding the first slide.
One by one, you ask a student.
Okay.
So it was written that the new product used to face the high failure rates. So what is the meaning of that high failure rates?
What do you mean by failure? So if you are going to develop a new product, so it is meant to fail, right? Because I've explained the challenges associated with the product. So it might fail due to several reasons, because suppose you have developed an ice cream and you want to sell that ice cream in Chennai. You have developed the ice cream in Jammu and Kashmir. So the weather condition in Jammu and Kashmir is totally different from Chennai. If the transportation is not well equipped to handle the product which you have developed in Jammu and Kashmir and you are trying to sell in Chennai, so it will eventually get failed. So this is a very basic examples I'm telling you. So like another example, I can say that your this let us say that if you have developed a scooter in US, or the your the US made foreign the speed cars, which they don't run in Indian roads. They cannot run in Indian roads for the simple reason because they are not having a the required ground clearance. In Indian roads required a certain ground clearance for the vehicles to run. So this if suppose you have made a new product and you have not considered all the required design parameters, then your product will fail. So unless and until your products hit the road, you cannot say that my product is bulletproof. Okay, that is the thing. Any other question?
Sir, higher return of investment. It means.
Sorry, which one?
So business challenge.
Okay, yes.
Business challenge. Higher
Yes.
return on investment.
Yes, because if the government or the funding agency which have invested so badly, so heavily in your product, so after 5 years, if you are not able to give high returns, then why should they invest on you? They will just simply keep that amount in bank and they will get an interest of 4.5 or 5. You ought to give them a rate of interest of 5%, greater than 5%, 6%, 7%, 10%. Then only you can tell, yes, father, please, your father, please invest in my company. I will give you good rate of returns on your principal. Please don't keep your money in bank. That is the thing. Okay.
Okay, sir.
Good. Any other question?
So I have one question in process challenges.
Yes, please.
In process challenges, universities lack resources or experience. Experience I know, but universities lack resources. That means.
Certain universities don't have the required resources to take forward the product or the process innovation, because there should be one dedicated lab which we have in our college. Like since we are talking about this IIC cell has arranged this talk, so some universities don't have that thing. So we have this thing, and if you have any ideas, then we will certainly take up those ideas, and in future we are going to see that that product sees the light at the end of the tunnel, you know.
Okay, sir.
Okay, any other questions? No. This MRL is basically used for checking the relative maturity and the risks related to manufacturing. So with this I can all say, and this slide represents the relation between TRL and MRL. So in basics you can see that Then in MRL also is the research produced in a lab environment and all those things. So MRL is not required at this stage. You first keep in mind the TRL thing. MRL, just to give you a flavor of the different levels associated with the readiness level, I have introduced TRL and IRL. So thank you. Thank you, participants.
Any other question? You can proceed it. Any other question, student? Okay. Thank you to nice presentation for the TRL section, sir. They are benefited that on that topic. The student will definitely benefited in future perspective. So thank you to all of you. And I think we close this meeting, student. And thank you, Prabas Banerjee, sir, Dr. Prabas Banerjee, sir, for
Thank you, sir. Thank you, sir.
talk
Thank you.
and brief up about that.
Thank you, sir.
Okay, thank you.
Thank you, sir.
Thank you, sir.
Thank you, everybody.
Thank you,
Kundu,
sir.
Yes, sir.
Kundu, sir.
Thank you, sir. Thank
Abhijit
you.
Kundu, sir, is there in this?
Thank you everyone for joining with us. Tomorrow we have another session because you know that tomorrow is National Energy Conservation Day. So tomorrow from 4:30 again we will meet, and our speaker already I have this spread this news to our Facebook page and as well as chat box that we have session with Dr. Kriti Mukherjee from UK. So please join with us from 4:30 tomorrow again. Thank you for attending with us. Have a nice day.
Thank you,
Have a
sir.
nice day, student, and tomorrow we will meet again. And number of participants will be more tomorrow also. Okay. Thank you to all of you.
Thank you all.
Thank you, sir. Thank you.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you.